Hello, my name is Daniel Franklin and I'm a physics student at Northern Kentucky University. Today I'll be talking about cosmic background microwaves. It's raining this morning, which is unfortunate. Why does it rain? As a matter of fact, why does anything happen at all? Well, to understand that, you have to understand the Big Bang Theory and essentially the birth of time in the universe. What happened was there was a single point of singularity. It's a terrible point, but it was infinitely small, so its volume was infinitely small, and all the mass that exists today in the universe was at that single point. And eventually something happened in the Big Bang, and all the mass in that side point was allowed to expand adiabatically. So on. Since all the mass inside that point was all the mass that exists in the current universe, this process had to do so adiabatically. And all that means is the volume and pressure expansion occurred without any transfer of energy, because all the energy that exists in the universe was inside that point. The reason cosmic background microwave is important to this is because as the photons that existed at this point in time expanded throughout the universe, the wavelengths that they would give off increased over time. And according to Planck's relationship, as the wavelength increases, the energy has to decrease. And we were able to observe this decrease in wavelength because as these photons existed, their energy decreased. So when we see photons giving off a wavelength of roughly 3.2 centimeters, we know they've been around for a long time, and those are the oldest ones we seem to be able to find. So that gives us a method of time dating roughly what happened and when happened. Cosmic background microwave was initially predicted by Ralph Alpher and Robert Herman, and based on the calculations they had at the time, none of their measurements were really that accurate, and for the most part the project was abandoned until Arno Penzias and Robert Wilson picked it back up accidentally when they were doing cosmology tests, and their equipment were picking up a temperature, a very small temperature around 4 Kelvin that they couldn't account for. And after long discussion and study, they determined it had to be the previously predicted cosmic background microwaves. After a little bit of study, they eventually got a Nobel Prize for that. But what they were picking up was the microwaves of the photons that I previously discussed, giving ever so slightly, just a small temperature increase. It's so widely studied now because it's probably one of the more easier and more accurate methods of proving the Big Bang Theory. And when something gives birth to all of physics, naturally it's a bit of an interest to us. So that's the basics of cosmic background microwave. Further studies should be able to show a likely starting point for the Big Bang Theory and almost precisely how long ago it was.